Hello everyone. In this video, we are going to explore the following question as you can see on the screen. This question is from Combinatorics. And this question says that there are 20 equally spaced points on a circle, say A1 through A20, and we have to find out how many ways can we choose 3 points such that no two are consecutive. It means in general version, we can say that it is a question of the number of ways the R points can be chosen from n points given on a circle and no 2 points are consecutive. So our aim is to derive the formula. By the way, so at first it feels like a standard counting problem, and it is in fact. But in the light of this question, several deeper ideas begin to emerge as we go through. And we get enlightened by not one, not two, but 3 sparkling formulas in the course. We will see how they are intertwined algebraically and how, in the light of double counting principle, they complement each other combinatorially also. So let's count on in the light of elegant reasoning. Let's dive in. Alright, so here we will go by the lighter version of this question. And for that, first we will understand the linear version of it. So linear version means I have taken this question for the linear understanding. So suppose I have 7 stations and the question says that in how many ways can a train be assigned stoppages at 3 stations and no 2 are consecutive. So these are the 7 stations I have already placed there. So the technique simply says in this way that you select any of the 3. So suppose you have selected S5, S6 and S7 for the choice of stoppages. And if I selected all these, so I have now only 4 stations. We don't care which are those. So it's a name to understand. So S1, S2, S3 and S4 are there. And in these 4 stations, there are gaps. So this gap 1, gap 2, gap 3, gap 4 and gap 5. So there are 5 gaps. And out of these 5 gaps, if I select 3 gaps, our work is done. Because on 3 gaps, I will station all these stations of choice, the S5, S6 and S7, and they will never be consecutive again. So S5 here, let's say S6 here. So now you can see that the S5 is our choice of a stoppage and S6 also our choice of a stoppage and S7. So you can now see that S5, S1, S6, S2, S7 and S5, S6, S7 are non-consecutive because between these 2 consecutive I have already S1 and S2 respectively. So in this way, this formula or this method or the technique will work in the linear situation. But suppose I want to transform it into the circular one. So now the question simply says that in circular that I have 7 stations and these 7 stations are in circular and train can be stopped any 3 stations but no 2 stations are consecutive. So what we can do in circular, what will happen that these 2 places what you have taken in this linear version is now considered to be 1. It means in all these linear counting there is 5C3. If I remove those countings in which the 2 places are not taken, then we can get the answer of our requirement. It means what we can see that these 2 places I am blocking, means this I am not choosing that. And in these 2 places, it means already we have stationed some choice of stoppages. I have put some stations. So let's say this is S7 I have put there and S6 is there. It means now I am left with only one station to be placed, but the choice of gaps I have only 3. So this I can do, that is 3C, and that is 1 only. Why? Because I have only one station left out. So in this all linear combinations or linear choices, I have also that choice included, but I don't want that choice, otherwise this will be counted as one single gap, correct? And I don't want the 2 stations there, so that's why I'm subtracting all those possible cases. So the answer should be the difference of these two, that is 5C3 and minus 3C1, so that is 10 minus 3, and that is 7. So 7 should be the answer of this circular. It means if I have 7 stations or 7 points on a circle, and I want to choose 3 non-consecutive points from them, so I will get 7 as the answer. Now let's try to make it a general version. So what you did actually, I had this for circular, I had n is equal to 7 because I have 7 total points, and I have to make the choice of r non-consecutive points. That means 3 non-consecutive points, so I will call it as r. So how this 5C3 is coming in terms of r, n and r? So you can notice that you have removed already 3 items from 7, so I'm left with n minus r items, and among these n minus r items, if I found the gap will be the total n minus r plus 1. Out of this n minus r plus 1 gaps, we are selecting r gaps because 3 items. So this is the linear version, and this is one formula you can copy or just keep it with you for the linear version of it. But for this whole circular version, what we are going to do, that from this formula n minus r plus 1 CR, that is n minus r plus 1 CR, we are subtracting something else. What we are subtracting, you see that the 2 gaps what we have already assigned for S6 and S7 is never be counted. It means out of n minus r plus 1 minus 2, we are selecting how many things? Because already we have given 2 items to those places. So out of r stoppages of our choice, I have only r minus 2 stoppage. Means it was originally 3 and we have given 2, it became 1. So this is the formula. Let's make it more simple. So that will become what the formula? N minus r plus 1 CR minus n minus r minus 1 CR minus 2. And that is the formula I am talking about. So you can see that this is the linear version of any such question in which if the 7 or the n items are on the line and I have to select 2 non-consecutive items, then this will be the formula for the linear one. And to make it circular, this is the whole thing for the circular choice. Means I have the 7 n items on the circle and I want to select r items in which no 2 consecutive are there. So in that way we have to use this thing as a formula, the ready-made formula for this question. So this is the first part of this video. Means if you want to go from here, you can just leave the video, because now it's derivation and everything. So if you don't like, the formula is already with you and you can skip the other parts. But the second part, who wants to go deeper, my point is this. The second part is, I want to derive this formula in a single expression. Means this is the difference, but I recommend that this is the very intuitive and what we call, it's a handy formula. It's an intuitive and handy formula because we know we make it linear and then make it circular. But suppose I want to explore more and try to find out a single expression formula, how we can find it? We simply simplify it. So the number of ways to select r non-consecutive r items from n items on a circle so that no two are consecutive. So for that, I want to simplify this formula. So n minus r plus 1 cr minus n minus r minus 1 cr minus 2. So I will calculate and then I will tell you what is happening. So here is the calculation so far, and you can go through this calculation and you can find it. I think it's not so difficult to calculate, so I wanted to convey the idea from here what I'm thinking. So this is going to be n minus r minus 1 factorial and divided by this whole piece, n minus 2r plus 1 factorial r minus 2 factorial. And if you simplify this, this will give you n square minus nr minus nr and plus r square plus n and minus r. And this will simplify, so it will give you minus r square and minus and minus plus r. And this whole thing is divided by r into r minus 1. So what we get here, you see the r square and r square will get cancelled. The r and r will get cancelled. And we get here the n minus r minus 1 factorial as it is divided by n minus 2r plus 1 factorial as it is, r minus 2 factorial as it is. But here n square and minus 2nr and plus n. And this is r into r minus 1. You can notice from there I can take n common. So let me write it in that way. So if I take this common n, I will get n out, and so I have n and then minus nr because actually n minus 2r, and that is n out, so plus 1. So what you can notice that if I expand this thing, this, let me just take it down first. Okay, what you can notice is if I expand this thing, sorry, not this one, this one, you can say this n minus 2r plus 1 will get cancelled. So we get here n minus r minus 1 factorial divided by n minus 2r plus 1 into n minus 2r factorial, and that is r minus 2 factorial as it is. And see here I have n into n minus 2r plus 1 divided by r into r minus 1, and they will get cancelled. So now I have a clean formula which can be written as n minus r minus 1 factorial divided by n minus 2r factorial, and this r minus 2 factorial, r and r minus 1 factorial all together can be written as r factorial, and this is going to be n. Now from here it's not that much a nice formula we have derived, but you can think better. It is divide and multiply by n minus r here. So what will happen is this n minus r we can take with that, and that will turn into n minus r factorial, and this is n minus 2r factorial only, and I have r factorial this side, and this is n by n minus r. If you can notice, what is this thing? This is nothing but, this guy is nothing but what? It is n minus r, that n minus, oops, yes, so n minus r c r. because if you expand it, you'll get the same thing, and into n by n minus r. So this is a formula you may find somewhere for this situation. So this is one formula we derived, but you can also notice one interesting thing is happening with the same formula. Let me take it here, and I had this formula here. Let me just take it down. So n minus r minus 1 factorial and divided by n minus 2r factorial and r factorial, and that was n. So this was one formula we already derived. How can we think it's a different thing also? So you can notice this is, suppose I'm dividing and multiplying by r only here. So I multiplied r here and divided r here and multiplied r there. So what will happen? That this whole thing will turn into n minus r minus 1 factorial. There is no change in the numerator. But denominator, I can cancel this r factorial with this r. It's not total r factorial, the factor r from the r factorial with this r. So we get n minus 2r factorial, and this is r minus 1 factorial. And this remains n by r, this guy. But now again you read this guy. If you read this whole thing, that will give you the idea. It is actually n minus r minus 1 cr minus 1. Can you notice? Because if I take the difference of these two, a 1 and 1 will cancel and get n minus 2r factorial here, and of course there, and that is n by r. Now I have this formula also, because it is emerging from the same same first formula, correct? So now in this case we can say that I have three different formulas. They are equivalent. What are those? The first was n minus r plus 1 c, what was that, r, I think, yes, minus, and that was n minus r minus 1 c r minus 2, and this is equivalent to this formula, that is n minus r cr into n by n minus r, and this is also equal to n minus r minus 1 c r minus 1 into n by r. So these are the three formulas we have discovered, of course. So the point is, these three formulas, how they are interconnected algebraically, we have already explored. Means we solved one and simplified this first one, and we get to the second, and simplified this thing, and we get to the second and the third. But my point is how this will make sense combinatorially also. Means, can we derive this formula without deriving this thing first and convert this thing into algebra? Means, convert this thing into that algebraically. Can we find this thing from the very scratch by just combinatorially thinking? And at the same time, can we find this thing by the combinatorially thinking the same formula? And if you notice, if I calculate this given question data in this formula, you'll get the same answer for both, because n was 7 there and r was 3 there. You can get that will be the same answer. Okay, so for that, let's discover this thing first, that how we can derive this thing combinatorially from the scratch. And again, I'm saying, if you are not okay with this kind of in-depth insight, you can skip this, because already you know three formulas. But I suggest you should dive in. So in this, we have to think in a circle only. We don't make it linear and everything. We will just understand everything in the circular path. So already I have this 7 stations, and I have this these are the choices actually. So I wanted to convey that if you just select S4, S6, S3, S5, S7 and so on, in this way we get the 7 choices of the stoppages. So we just by hand we also count, we get the 7 as an answer. But the problem only occurs when we have 20 or such big numbers. So that's why we are discovering the formula. Already we have discovered, but we have to understand in a different way. So the idea is that again we have the same kind of approach, that we select first 3 stations and we just count the gaps and place those stations in the gaps. But the problem is, in circular, there is some kind of thing that we make a choice, and that choice will be overcounted. So let's see how we want to convey this thing. So suppose we have this S5, S6 and S7 I have selected for my choice of stoppages. So S5, S6 and S7 I have selected from stoppages, means this will give you one other gap. What do you want to convey? Let's see here. So I have taken, so let's say this is a one gap I have from here to here. So let's call it gap 1, and this is gap 2, gap 3 and gap 4, because I want the stoppages what I have chosen to be placed in that. It means let me write them the name in the ascending, let us say the clockwise order. So G1, G2, G3 and this whole thing is G4. So suppose we substitute there in this gap the S5, then here S6 and then here S7. So this work is over, because now you just see that all the choice of our stoppages, the stoppages what we chosen, they are not consecutive, because S1, S5, S2 and S6 and coming. This is the choice of stoppages. But some can think that, okay, if I take this G1 gap 1 here, but I am substituting S5 in this gap, S5, S6 and S7. This is also correct, because now I am thinking this is our gap 1, this was our gap 2, this was our gap 3, and this overall gap I had already as gap 4. So wherever you put, maybe S7 is here you put, but doesn't matter, it's a gap. But the problem in this thing is, you can see that, okay, suppose I have this, how many gaps we left? 4 gaps, and there are 3 members. So I can say that this should be 4C3. But 4C3 is not the correct answer for this situation. Why? Because the idea is that suppose you select this G2, G3 and G4 for the gap. In this case also we have the same choice. Why? Let's think in this way. In this particular choice, because we are selecting, we are not arranging. So in this particular choice, when we have placed this S5 in gap 1 and S6 in gap 2 and S7 in gap 3, we can say that there are the points S1, S2, S3 and S4 are not selected for the choice of stoppages, and only S5, S6, S7 are selected from the choice for the choice of stoppages. So basically we are selecting the stoppages which are non-consecutive, but we are thinking in the circular by making into the gap to place those points. So what is happening, if you just think in, see this whole scenario in the choice of stoppages and not choice of stoppages, or you can say the favorable choice and not favorable choice, or chosen points or not chosen points, that will give the everything clear. Why? Because in this scenario, the case 1 also, you have the chosen points S2, S3, chosen points S5, S6, S7, but non-chosen points are S2, S3, S4, S1, S2, S3, S4. In the second scenario also, wherever you give this S5, S6, S7, the other gaps, it will give the same choices, because S5, S6, S7 are chosen and S1, S2, S3, S4 are unchosen. And doesn't matter how many cases you create, because the gap you have taken 4 gaps in this scenario. So we can also place, because we have taken this S5 starting from here, I can say that the S5 will go here, then S6 will go here, and S7 and so on. So this will also give you the non-two consecutive things, but still is the same scenario. So why it is happening? Because there are 4 gaps. So for each gap, you have actually for each, not gaps, for each choice of the 3 points, you have counted this choice 4 times. Please understand what I'm repeating again. That for the choice of the 3 points, you have repeated that particular choice 4 times, because when we are selecting the gaps for this, the gaps selection will not give you the different choice every time. So the idea is that because we have selected this choice is repeated 4 times, I have to divide by 4 times. It's our duty. But again, this is not the answer. The answer is coming as 1 here. But why is this thing? Because again, what happening? Because we don't know from which point we have taken the reference. So how many points are there? There are 7 points. Therefore, we have to multiply this whole thing by 7. So the thing is, the 4C3 is indicating that suppose I have n total numbers. So I'm selecting R members. They're non-consecutive. 2 are non-consecutive. So what we simply do that n minus R. I have the number of gaps, because R you have already removed from that, and out of this n minus R you are selecting R gaps. Yes or no? Because you see that here also out of 4 gaps, if you remove this in circular, there is no extra gap because this is it completes the loop. So from out of n minus R gaps, you are selecting R gaps to place them. But for each, let me repeat again, just please understand very carefully what I'm saying, that for each R choices, we are counting that each choice n minus R times. For each R choices, we are counting that each choice n minus R times. For each, this 3 choice, we have counted each choice 4 times. Each 3 choice means S1, S2, S3 can be our choice, S5, S6, S7 can be our choice. In the same way, this for each R choice, I'm counting each choice how many times? N minus R times. So our duty is to divide by n minus R. And because I don't know from where I'm starting, because if you give S1, S2, S3, the S1 is the starting point, or S5, S6, S7. So these are actually done in n different ways. So therefore we multiply by n. And that is the whole thing I wanted to convey for the first formula we derived algebraically. If you are not understanding, please go through again and you will understand. Now the second formula is this one. How do we decode it? So for that, for this formula, we thought everything in the gaps form. But here we don't have to think in this way. We have to think in a different way. What is a different way? Suppose I have already placed those choice of stations. Means, suppose I have station 1, station 2, station 3, station 4. Let me just put all of them. S5, S6 and S7. So here again the similar scenario. What I'm doing there, let's say I have this choice of a station, I'm taking S1. Then I'm taking S3 for the choice, and let's say I took this S5. So basically you have already taken this 3 stations of choice, and if you want them to be non-consecutive, it means that you are saying that between these 2 stations I must have some stations there. Between these 2 stations of choice I must have some stations there, and again between these 2 I must have some stations, but I don't know how many. So I can simply take that, okay, let's say this is the A, the number of A denotes the number of stations between them, because I don't know how many stations you will choose between them. The number, you can also say that, let's say between S5 and S6, this is also denoting one number, let's say it's a B, and from there to there I can say there's a C. So these are the only three possible numbers we can have, because only you have taken S1, S3 and S5 as our choice of stations which are non-consecutive, because there are three only. So these are the only three gaps we make between them, so that each gap will contain some number of stations. But the idea is that total number of stations was n. You have already removed r. It means this A plus B plus C must be n minus r. Yes or no? Because you have already removed r out of it, out of n. So for the choice of your stoppages, I must have A plus B plus C is equal to n minus r. And you know how to, but the thing is, the A should be equal to 1, I mean greater than equal to 1, because if I take all the things 0, A, B, C 0, it will never be any stations between two choices of stoppages, and that will become consecutive. So A must be equal to 1, B must be equal to 1, and C must be equal to 1. And you know how to solve it, because it's just asking the number of ways how many such integers can be selected to give n minus r. And know the formula is n minus r minus 1, cr minus 1. We found it, but again, for each such choice, you have counted extra. What you have counted extra? Can you guess? Because you have r such choices, I have counted this thing r times. But again, we don't know what is the starting point. I have to multiply by n, because there are n such starting point you can make. And so the answer is again n by r, n minus r minus 1, cr minus 1. So this is again, it makes sense in circular way. Okay, so that is the whole take of mine on this topic, and I hope you understood it. If you're not understood, please go through it, but still you have a formula. Even if you don't understand, you can apply the formula and get the answer. But first of all, you have to identify the question is of this kind is not. So let's go to the original question I have. So this was the original question, and now I think you can find it because you know the value of n and the value of r. From this all formulas you can apply and see whether the answer is same or not. The answer for this question is, I think, 800 perhaps. So let me calculate it. 17, 16, 15, and that is 3, 2, 1. And here 20 by 17, 17 cancel, and I have 3 5s are 15 and 2 10s, okay, so 80 and 800. So in this way, any formula you will apply, you will get the same answer. And now you know the three formulas which can be helpful. So I think you got enlightened in this whole discussion, and you'll apply it in your any problem of such kind. See you in the next video with some other in-depth concept. Stay math active.